So now we're going to write our code for merge sort. And we'll start our code off like this, and we're going to pass it this list. And on the right side of the screen, I'm going to bring in a call stack, and I'm going to add an instance of merge sort to the call stack. So merge sort is going to be called recursively. So we're going to have multiple instances of merge sort on the call stack. And each instance is going to be called with a list. So to keep track of what list each instance of merge sort was called with, I'm going to do this. So now we're going to split that list in half. And in order to do that, we're going to need a midpoint. We'll call that mid index. And we're going to set the mid index to be equal to the length of the list divided by 2. So in this case, the length is 4 divided by 2 is 2. Now, one of the things we have to do here is to account for when we have an odd number in the list. So for example, if we had a list with 3 items in it and we divide by 2, we're going to get 1.5. And we can't have an index of 1.5. So we're going to change this into an integer. And in the situation where the mid index would be 1.5, everything to the right of the decimal place would be dropped and the mid index would be 1. But in this situation, because we have 4 items, the mid index is 2. And that is this index here. So I'm going to take that 2 and store it next to this instance of merge sort. That's mid index for this instance. So now we're going to create 2 new lists. The first one we'll call left. We'll set it equal to my list on this range. So when you do a range like this with this colon, whatever's on the left, that's the starting point. If you don't have anything on the left, the starting point becomes the first item. And we go up to, but not including the index that's on the right of the colon. So mid index is this. And when we go up to, but not including, we're going up to this index. So left is going to be a new list with these 2 values in it. And then we'll do the same thing on the other side. We'll say right equals my list on this range. So on the left of the colon, we have mid index. That's the starting point. That will be here. And if we don't have anything on the right of the colon, we just go to the end. So that means we're going to create a new list with these 2 values in it. So left and right will be these 2 new lists. Then we call merge. That's the helper function that we wrote in the last video, and we call it on left and right. But there's a problem here. Merge only works on sorted lists, and neither one of these lists is sorted. What we need to do is break each of these lists in half, and we do that with these 3 lines of code. And specifically, the splitting happens with this code here. And this did exactly what it was supposed to do. We just need to do it again. So this is where we call merge sort recursively. So now let's take these 2 lists, put them back together, and we're going to start this over. So we've already calculated the mid index. We know that's the index of 2. And then when we come down here, this portion of the code does exactly what it did before. It's just going to create this new list with 2 items in it. The difference is we're going to call merge sort on that new list. So we'll add this to the call stack with this list. So now this becomes the active instance on the call stack. So for this instance of merge sort, we're going to start out by calculating the mid index on this list. So the length of this list is 2, divided by 2 is 1. This is going to be the mid index. So then we come down to this line, and this portion here is going to create a new list of just 1 item. And I colored this green because a 1 item list is by definition sorted. But we're going to call merge sort on that list. So we'll add this to the call stack on this list. And since this list has 1 item in it, we don't want to run these 3 lines to try to break the list in half. This is our base case. So we're going to say if the length of the list is 1, and that is the case here, we're going to return my list. So in this return statement, where does it return it? It's going to return it to the function that called it. And once the return is run, this gets popped from the call stack. So now this becomes the active instance on the call stack again. And this was the last line that it ran. So it ran this in order to determine what left would be for that instance of merge sort. So I'll put this back, and now we'll move to this line. So this portion here is going to create this list, and we're going to call merge sort on that list. And now this becomes the active instance of merge sort on the call stack. The first thing we'll do is check to see, is the length equal to 1? It is, and we're going to return my list, and this gets popped from the call stack. So this becomes the active instance of merge sort on the call stack again. We just ran this line, and this one item list is right. So now we move down to here, and we're going to run merge on left and right. So we'll add this to the call stack on left and right, and that's going to do this. So this line here, I'm going to remove the return to show what this does. So the merge function has a return statement in it. So where does it return to? It returns to here. And once it runs that return, this instance of merge gets popped from the call stack. So now this is the active instance, but it has this return statement in here. It's going to return whatever merge returned to it, which means it's going to take this list and return it to here. And once it does that, that is popped from the call stack. So now this is the active instance on the call stack. We just ran this and determined that left equals this sorted list. So I'll put this back, and we'll move to this line of code. So remember, this is being called on that 4-item list. So right is going to be these 2 items, so that right side of that 4-item list, except we're going to call merge sort on it. We'll add this to the call stack, and it's being called on this list. So now this becomes the active instance of merge sort on the call stack. We're going to check to see if the length is 1. It is not. So now we'll calculate mid index, and that's going to be this item. And then we move down to here. This portion is going to create this 1-item list. We're going to call merge sort on that. And now this becomes the active instance. We'll check to see if the length is 1. It is, and we'll return my list, and this gets popped from the call stack. So now this is the active instance again. We just determined that this 1-item list is going to be left. Now we move to here. So this portion here is going to create this 1-item list, and we're going to call merge sort on that 1-item list. And now this becomes the active instance. We'll check to see if the length is 1. It is. We'll return that 1-item list, and this gets popped from the call stack. So now for this instance of merge sort, we have determined left and right. Now we move down to here and call merge on left and right. We'll add this to the call stack with both of those 1-item lists. And that does this, and I'll do that same thing where I remove the return. Merge is going to return this list to here. That gets popped from the call stack. But this instance of merge sort, because it has this return, is going to take this list and pass it down to here. And when it does that, it gets popped from the call stack. And I'll move this back up here. And now this is the active instance again. We have found left and right for this instance of merge sort, which are these 2 sorted lists. Now we move down to here. And we're going to run merge on these 2 lists. We'll add that to the call stack on these 2 lists, and that is going to do this. So I'll remove that return from the code again. Merge is going to return this list to here, and that is popped from the call stack. But because this instance of merge sort has this return statement, it's going to return this somewhere. And the place that this gets returned to is the original function call. It's going to return it to here. And once it does that, this instance of merge sort is popped from the call stack. And now we have this sorted list. So we'll look at this code in a moment in VS Code, and when we do, we'll start out with a list that looks like this, and we'll run merge sort and return a sorted list. So now let's flip over and take a look at this. So there is our merge sort function there, and I'll scroll up. So this is going to be the list that we pass to merge sort, and I'm calling this original list. And then I'm going to have a separate list called sorted list that is equal to merge sort on the original list. So merge sort is different than the other sorting algorithms that we've seen so far. The other sorting algorithms sort the list in place. That is to say that the original list will be sorted when we're done. But with merge sort, the original list stays the same, and it returns a separate sorted list. So now I'll run this, and you can see that our original list is unchanged, and there is a separate sorted list that was returned. And that is our function for merge sort.